We are in Precalculus lesson 1-8, magnitude and direction of complex numbers. Today's date is Friday, September 11th, 9/11/2020. I'm on my new tablet that I got, guys. I don't know if you can see my video. Mr. Brown and I just got new tablets delivered yesterday after school finished, so it's way nice. Well, it's not way nicer. It's a tablet that actually works now, so that's cool. Mr. Burns has requested to read our objective. Go for it.
Find the magnitude and direction of complex numbers.
All right. There it is. So, vocab, absolute value. You guys have seen this before, hopefully in like 8th or 7th grade, but it's the same definition that we're going to be talking about. Distance from what with a quiet raised hand? It's from a certain number. Distance from 5, distance from 7, distance from anyone? Yeah, Elliot?
From 0?
From 0, yeah. Our distance from 0, okay. And then when we're talking about our class, now that we're dealing with complex numbers, there are a few different synonyms that you need to know. So the easiest one for us that I think everyone can understand is length. But you might notice that that word is not in our title. It doesn't say length of complex numbers. So direction doesn't make sense. It's magnitude. That is the other synonym that you need to know. So length and magnitude, same word. Magnitude. So now from here on out, when I say the word magnitude, you should be auto-translating that in your head. Oh, Mr. Sandell is talking about the length. And what length am I talking about? The length from the origin of the complex plane that you've been graphing these numbers on. All right, so let's actually see some graphical stuff. I can leave that stuff down here. The distance of 5 plus 2i from 0, it's essentially asking what is the magnitude of this complex number 5 plus 2i. It's the same way of asking it. If I asked what the distance from 5 plus 2i from 1 is, that's not talking about magnitude anymore. But since it's from 0, that is the definition of magnitude. Let's find that distance. Well, here, I'll draw a line. Ready? So go up to my line tool and draw a blue line from our start to our end. Boom, boom. I need to find the length of that line. This is a geometry question now, right? How do we do this in geometry? Anyone have an idea? The length of a diagonal. Ellery has an idea, but I want to see some more hands. Beverly has an idea. We'll go to Beverly. I haven't heard from you yet.
Is it the a squared plus b squared equals c squared?
It is indeed, yeah. So if I have a length over here, I'll do that one in orange, a length down here, let's do that one in green. We have to figure out what those lengths are, and then we're going to use that a squared plus b squared equals c squared formula that Beverly's talking about, which is called Pythagorean theorem. So I can come over here and say, I can color code this too. I can make it look really nice. I can say a squared plus b squared, that's equal to our blue c squared. And again, we're trying to find just c by itself. So I'm going to call this length here c. But I know the length of b. B, I can just count up 1, 2. It's 2. 2 is equal to b. And I know the length of a. Again, I can count 5 to the right. 5. Ooh, I want to change my color to green. A is equal to 5. And I'm just going to plug those into my formula. So here we go. I have 5 squared plus our 2 squared is equal to our c squared, which again, we don't know, so I'm going to leave it as c squared. All right, I need one volunteer to walk me through 1 or 2 steps. What do I do through here? Remind me that you have passed geometry. I see Beverly's hand, but again, I'm going to try calling someone new. This should be review from our distant past now. We took Algebra 2 last year. The year before that was geometry. Yeah, Emily.
It's going to be 25 plus 4.
Indeed, is equal to c squared. Do you mind doing one more step for me and add those 2 together?
It's going to be 29.
There it is. 29 is equal to c squared. And someone new, what do I do now? I want C by itself. Right now C is being squared. How do I unsquare C? What is the inverse operation of squaring a number? Yeah, Caroline?
Square root.
There it is. So take the square root of both sides, and therefore C is equal to plus or minus the square root of 29, which you can't reduce. I mean, it doesn't make sense to think of a negative 29. It's not really in the domain when I'm asking a question on what is the distance. If I say, what is the distance between me at Levine High School and your house, you're not going to reply a negative amount. Distance is always a positive number. So I'm going to go ahead and get rid of the negative. But just be careful. Every single time that you take the square root, it is always plus or minus, and then you have to think about the domain. Does this make sense? No, a negative does not make sense in this case. It's just positive square root of 29. And that's the answer, done. You've now done you found the magnitude of this complex number 5 plus 2i. It's square root of 29. So magnitude up here in our notes, I'm going to add all the way back up here, guys. Magnitude has a symbolic representation so that we can write this faster. I don't want to write out magnitude every single time. I just want to write out these symbols. Chunk, chunk. It's just absolute value symbols, right? So the magnitude of this complex number z. So, and here it is. I'm writing down our formula down here. If I have the complex number z, which can be represented as a plus bi, or I could have written it as just z, what is our generalized formula? What did we do up here? I want to create a shortcut. You can always do it the long way. And really, if you don't mind turning your camera back on, you can always do it the long way of using the Pythagorean theorem over and over again. But here's the shortcut if you want to use it. And since our quizzes and tests, while we're doing Zoom distance learning, are all open note. Once you come back in classroom, it's not going to be open note anymore. But for now, it's open note. You might want this formula, right? And Jaden, I don't think it's been 20 minutes yet, and you haven't participated twice. So if you can turn your camera back on, please, I'd appreciate it. Our formula. Well, first you have to square the two things. I have to square this number and square this number, right? And be careful that I'm not squaring the I. Really, we only wanted the length here, b. I could have said that this length is 2i because I'm going up in the imaginary direction, but I really only wanted to grab the length. So I'm not going to include the I here. I'm only going to say the b. So what do? We squared both of those. We had a and b squared. So I'm going to say over here, we had a squared, and we also added that to b squared. So we added them together. Emily added those together. And then Caroline square rooted that for us. So I just need to square root that for us. And hey, there's your quick little shortcut. Every single time that you're looking for the magnitude of any complex number, just take a squared, b squared, square it. And remember, my note to you guys is don't accidentally square the I and think, oh, it's a negative, which means I'm subtracting, I'm doing a squared minus b squared. No, don't use the I, only use the a, only use the b. So right up here, don't use I, just use the b. All right, so let's try out our fancy new formula and see if we can figure out what the absolute value or the magnitude, I could have said, what is the magnitude of this complex number, -2 plus 3i. So I'll let you guys get a head start on me, and then I'll ask you guys in about 30 seconds to help me out. So any volunteers? Tell me what to do. You're just plugging into a formula essentially, right? So I need someone new. Sorry, Beverly. But thank you for raising your hand. I believe that you know what you're doing. And you can go ahead of us if you need to. What do I do? By the way, Khan Academy assignments are up online if you want to spend your free time doing that instead of getting ahead in the notes. You can do that. We have 2 assignments, one on finding the magnitude of complex numbers, what we're doing right now, and then the back side of our notes, that's another homework assignment, how to find direction or the angle. All right, someone new. I feel like calling on Oscar. Oscar, just plug into this formula. Tell me what to do.
All right, so is it -2 squared?
Yep, -2 squared.
Plus 3 squared?
Plus 3 squared. And then what do we do to all of that?
And then you with that thing.
The
I have
thing,
a brain freeze. What is it called?
square root.
Yeah, square root. Sorry, I had a brain
Yeah, you're
fart.
good. We all have those brain farts. I have them at least once a day. Yeah, square root of all that stuff. And Oscar, do you want to keep some flying, or do you want to give it to someone else?
Can I give it to someone else? Because I'm not really sure how to do that
Yeah,
part.
for sure. All right, I need another volunteer. Tell me what -2 squared is. Tell me what 3 squared is, and then add them, and then we're done. Aurelio. Oh, yeah, Caroline, your hand is up, but I'm going to call on someone new. Aurelio. Aurelio, what is -2 squared?
What's up? I was not
What is
paying attention.
-2 squared? What is -2 times -2, Aurelio? What is 2 times 2, Aurelio?
Oh, I was on mute. I said 4.
Oh, 4, yes. And then what about 3 squared?
6.
Careful, 3 times 3,
Oh, 9.
9. And then add them together.
13.
There it is, square root of 13. Aurelio and Oscar have worked together to find the absolute value or the magnitude of -2 plus 3i. All right, so I think you guys probably get it from there for the rest of the homework, but let's go into the second assignment. How do you find the angle? How do you find the direction of all of these complex numbers? And really what I'm looking for here is, if I came back up to this previous example, I'm asking for, what is this angle right here? Tell me what that angle is. That'll tell me the direction. I mean, mathematicians could have defined it as like this angle or maybe that angle, but typically it's the angle from the real axis that we're asking. So down here, I'm kind of doing the same, if my computer would load. I'm asking, what is that angle? What is that unknown angle? And to figure that out, we need to use trigonometry. And it always comes back to haunt us. You have to have these previous skills for all of these classes. You need to have geometry's Pythagorean theorem. You have to have geometry's trigonometry. Everything in math just keeps building on each other, getting more and more complex and awesome. All right, so we can only use trigonometry, though, if we have a certain type of shape. What is that shape that we need to have trigonometry? Earlier, yeah, thank you. Someone new, who have I not called on? Leo, what type of shape is this thing? What is this? This shape right here. It's not a circle.
Triangle.
Triangle. And what type of triangle?
Is it a right triangle?
It is indeed. Yeah, everyone write it down. So Leo said we can only use trig when there is a right triangle. So that means if we have some random point floating out in complex space on our complex plane, we need to make the legs of the triangle so that it's a right triangle. Like, I don't think I've ever seen a student do this, but it would be kind of comical if I had a point up here on the complex plane, you're like, make a triangle, and you're like, okay, and then your triangle is like weird looking, I don't know, something that looks like that. You have to have a right triangle. So draw a line straight down to the real axis, a line straight across to the imaginary axis, and look at your right triangle. Okay, and then remind me, SOHCAHTOA, what are those? Sine is equal to something over something. Do you remember SOHCAHTOA? Has everyone participated already? I think so. Oh no, Cohen, SOHCAHTOA, help us out. Tell us anything that you know about SOHCAHTOA, either labeling the triangle with hypotenuse, opposite, adjacent, telling me that sine is this divided by this. What have you got?
So the adjacent is going to be the line that's next to the angle, and that is across from the right angle.
So across from the right angle, this line right here is the adjacent?
Yeah.
Close. So remember that the diagonal one is always going to be the hypotenuse. But I like the definition that you gave. It's always the one that's next to it, right? So the hypotenuse is always the diagonal. And then the one that is next to the angle that isn't the hypotenuse is our adjacent. Yeah, thank you. And that, therefore, that means that this line segment is what?
The
Remember?
opposite.
There. Thank you. All right, everyone's in. I can get multiple people participating. Thank you, Cohen. What is sine? Someone. I think Ellery had her hand raised. Yeah, Ellery, go for it.
Sine is opposite over hypotenuse.
Opposite over hypotenuse. Perfect. Cosine. Someone else. Beverly.
Adjacent over hypotenuse.
It is indeed adjacent over hypotenuse. And if you're sounding these things out, it makes you sound kind of silly, but so S-O-H, so, oa. How do we make the oa sound? Someone aside from Ellery and Beverly. What is our fraction? Oa. Caroline, go for it.
Opposite over adjacent.
There it is. Opposite over, oh, got some lag there. Adjacent. Yeah, and if you ever need to write it out, SOHCAHTOA, the way that we typically write it is S-O-H-C-A-H-T-O-A. SOHCAHTOA. All right, so we have those memorized. So we need to be able to know how to solve for theta. That's the whole purpose, right? What is the angle? So we're going to use tangent. Why are we going to use tangent? Because we will always have legs on the right triangle. And I should have made that a question. But if I always draw a line down to the real axis, if I always draw a line to the imaginary axis, I will always have an opposite and I'll always have an adjacent, which means I'll always have this fraction. So let's just make up a number. I made it up a number 1 just for, I don't know, to make it simple. This could be any fraction. It could be 2/3. It could be a decimal, 0.389, and it goes on forever. Some number. But we know that that number is represented by opposite divided by adjacent. So that's what's being put right here. That number is some number that's opposite over adjacent. And I know tan of that angle is equal to opposite over adjacent. How do I now undo tangent to solve for theta? Ellery?
It's up to like arc tangent thing.
Exactly, yeah. So there's,
tangent.
yeah, so there's 2 ways of writing it. You can say tan to the -1, which isn't really -1 power. This is pronounced arctangent of both sides. So I take arctangent of the right and the left side. By the way, if you want, you can say it differently. Arctangent can be written tan to the -1, or you can actually write out arctan. Both of these in the calculator, in terms of the Desmos scientific calculator, will work. And arctan is a little bit easier for me because I can just type it with letters instead of trying to find shift-6 to raise the power of -1, stuff like that. Okay, we've taken the arctangent of both sides, and arctangent and tangent, as Ellery stated, cancel each other out, and I'm left with theta, which is equal to, I can't do anything over there, just arctangent of 1. And we've solved it. Ta-da! And you can actually plug it in on your calculator too. What is arctangent of 1? And I think you should get like something like pi/4 if you're in radians, or 45 degrees if you're in degrees. So that's how you solve for it. I guess I should show you on the calculator how to do this. So we're here. Let's go to, I'm going to share my entire desktop. That way you can see me when I Alt-Tab and use my Spotlight search. So if I come over here, go to desmos.com/scientific. Let's practice typing this in. I told you 2 ways to do it, but let me prove it to you. It would load. I'll leave it on the notes until that loads in the background. It's done. There it is. Okay. I'll zoom in here twice. Yep. I think that's maybe too big. Okay. I can either type in arctangent of 1, or I can type in tan to the shift-6, so the power of -1 of 1. Either way, 45, if I'm in degrees, and you can switch it to radians, and that turn into pi/4. If you don't believe me that that's pi/4, you can type in pi/4, and hopefully now you believe me when I switch into radians. Cool. So that's how you do it on the calculator. Use the desmos.com/scientific calculator because it makes it really, really nice. And I would probably use this one because you can type it in really quickly. Or you could just find the functions button and come over here to this arctangent button if you don't like typing. Switching back to the notes, let's go on to the back side of the notes. Does anyone need the front side still? Quite raise hand. Need more time? No one needs more time. All right, we're going on to finding direction and actual formula. Here we go. So I'm going to randomly pick a point, 5 plus negative 5 plus 2i, and I'm going to go ahead and draw a line that goes out to that point. So I'll just do a blue line, shoink. And I'll also have a new line. What have I been using for the x? So I've been using the real direction. I've been using green. If my computer wasn't so laggy, this would be easier. And then for my imaginary direction, I'm using this orange. I have to do it to the side because otherwise it'll move stuff around and drag it into the right spot. Okay, so there's my right triangle. Again, I'm trying to figure out what is our angle. And you have to be careful because our angle is always measured not from just any plain old real axis, but from the positive real axis. So I'm really trying to find what is this angle right here. That's our true theta. But to start finding that, it would be helpful to find this other theta. I guess we should use a different variable. What Greek letter do I want to use? I can use alpha. Alpha's fun to draw. It looks like a little fish. I'll call that mini angle inside there alpha, but we're really trying to find theta because it's always measured from the positive real axis. Okay, how do we do that? Well, let's just give this, let's do the math off to the side really quickly. I have to find the length of our orange, length of the green, and then do that operation that I just talked about up here. Who can help me do that? Just kind of regurgitate what I've just been saying. Count squares if you must. I think Ellery just did it last time. I need to get at least flip-flop between people that participate. Someone tell me, what is the length of our orange line? What is the length of our green line? Line segment, I should say. Oscar.
1i, or just 1? Oh wait, my bad. It's 2. I'm sorry.
2,
I'm sorry.
yeah. You're good, yeah. And you're right,
2.
it is technically 2i because going in the I direction. I'm just gonna say 2 because I'm trying to boil down our complex into like normal geometry. What about the green? Do you have that one too, Oscar?
-5. -5.
-5. And if it's -5, it makes it easier. If I go down, make it -2. If it goes up, +2. If it goes left, make it -5. If it goes right, make it +5. If you do that, it will be a little bit easier for you guys. Although if you did +5, it's not that challenging to make it work. All right, so here we go. We're actually doing the trig now. Who can set up our formula? I'll do the first part for you guys. Ready? Here goes. Our formula says tangent, come on, computer, catch up. It's lagging, it's still lagging. There it goes. Tangent of theta is equal to, oh my God, why is it lagging so bad? There it goes. Tangent of theta is equal to opposite over adjacent. So what fraction is it? 2 over -5 or -5 over 2? Someone help me. What's my fraction? Someone aside from Oscar. Beverly.
2 over -5.
There it is, 2 over -5. And I guess I can color code those, right? So 2 is our orange. 2 over, and then -5 is green. Cool. And then Ellery had the correct step last time, but someone aside from Ellery and aside from Beverly, since you just did it, what do I do to both sides to solve for theta? Again, I'm trying to solve for theta. Look back right up here. What did we do to both sides to get rid of the tangent, to undo tangent, to get theta by itself? We'll give it to Jaden. You haven't done any math today. Well, any
I don't even know.
with
Like,
math.
wasting your time. Like, I'm not trying to be rude, but I don't know.
I'm gonna help you through it. I'm gonna help you through it. Don't worry. Here we go.
You
Ready?
can try. I mean, I'm not.
Okay, so look at what Ellery did up here. We had just this tangent of theta is equal to 1, and she took the arctangent of both sides.
Arctangent.
And look how that relates to our case. Our case, we have tangent of theta again is equal to a fraction over here. What do you think we should do to both sides?
The tangent of theta.
So we already have tangent of theta. Do you remember the word for the reverse of tangent?
Back left. Arctangent. I don't
There
know.
it is. Yeah, you got it.
Oh.
Yeah, thank you. So everyone follow Jaden. We're taking the arctangent of both sides. So arctangent of both sides. And this is now where the arctangent and tangent cancel each other out. I'm left with just theta is equal to this arctangent
Oh no, Dylan.
of 2/5. And we have to use our calculator for this. So I'm going to leave this up on the screen for like 10 seconds, and then I'll switch over to my calculator. All right, so arctangent of, I have it on my negative point. There it is. Okay. Come over to my calculator. I want to go arctangent of 2 over -5. And we get this angle, which is interesting, negative 21.8 degrees. So come over here, and I'm just thinking, wait, what? Negative 21.8 degrees? Negative 21.8 degrees? And then you should be like scratching your head. That doesn't make sense. It does once you know the next step. But that is the calculator is a dumb calculator. It doesn't know, like, wait, you're trying to put this on a plane? So here is my solution on what the heck is going on. Okay, so if you guys remember this acronym, all students take calculus. And you can make this a dirtier acronym if you need it. But all students take calculus means these are the functions that are always positive in each quadrant. A stands for all. All sine, tangent, and cosine, they're always positive in this quadrant. In the top left, only sine is positive and tangent and cosine are negative. Bottom left, tangent is positive, sine and cosine are negative. And then in the bottom right, cosine is positive and sine and tangent are always negative. Well, hey, look at this. Well, it spit out negative 21.8 because by default, tangent is always going to spit out a value that is in the right-hand quad, or in the right two quadrants. So in quadrant 1 and quadrant 4, that's where tangent is always going to put you. It's like it's domain. I don't know if that's the right word, but it's always going to shove out a number that's in quadrant 1 and quadrant 4. So if you are looking to try to get your answer into quadrant 2 or quadrant 3 on the left 2, then you need to add 180 degrees. And that's just a universal rule. Always add 180 degrees if you're trying to get in the domain between 0 and 360 degrees. So here's my handy little chart for you guys. So if you draw the quadrant and you're over on the left-hand side, so in this area on the left, you need to always add 180 degrees. And we are, look, our point right here is in the left, so we need to add 180 degrees. So I need to come down here and say, well, we had negative 21.8. I need to add 180 degrees. And if you don't want to do math like me, I'm going to go ahead and use a calculator. 180 degrees, that's 158.2. So come down here and say our real answer is 158.2 degrees. Box it. There it is. And then I'll give you the formula in the last 30 seconds that we have of class. You can try doing these examples on your own. I'm going to do the rest of this video in a sec. But here's the formula. The formula is this. Do the arctangent of, notice it's always the imaginary divided by the real. So I'm going to say imaginary divided by the real. That's step 1. And then, so step 1, and then step 2. If you are in these quadrants over here on the left, then you have to add 180. Bada bing, bada boom. And I was wondering, why did I leave that chart there? It's so that I can say, if you're over here on the left, you need to add 180 degrees. I didn't need to make my own chart. So if you're in quadrant 2 or quadrant 3, typically you draw Roman numerals, you need to add 180 degrees for those quadrants if that's where your angle is supposed to be. Because by default, tangent will only spit out an angle that's in quadrant 1 or 4. But if you started with in quadrant 1 or 4, then you're done. You don't need to add 180 degrees. You're just there. Although now that I'm thinking about it, we always want a positive value too. Okay, so I might need to make a tiny little addition to this rule, but I'll let you guys get out here. I'll stop the video here.
Mr. Sindel,
Yes.
I have a question.
The rule that we said was if you were in quadrant 2 or 3, you need to add 180 degrees. And maybe it's worthwhile saying like add 180 applies to that quadrant, and maybe I should write it again, 180 degrees. That is a true rule. I noticed that in Khan Academy, most of the time it wants your domain between 0 and 100. So if you have your theta, your angle, typically it's going to be between 0 and 360 degrees. So 360 degrees and 0. But what happens is if you have the arctan function, arctan will always spit you out up here or down here. If it's in the first quadrant, then you're good. Like you can give yourself the check. You don't have to do any extra step, but you do have to do an additional extra step if you're in quadrant 4. So this is quadrant IV, quadrant 4 down here. If that happens, you don't have to add 180 degrees, but you do have to add 360 degrees. Why? Because this angle down here, it counts it as negative 45 degrees, which is correct, except it's not in the correct domain that it's asking for. So you need to just move it by adding 360 degrees. No matter what you do, if you add 360 degrees, it's right back to where I started with, just a slightly different number now. I guess I'll add step 3 down here too. If, I can't spell, if you're in this quadrant in the bottom right, then add 360 degrees. Let's do example number 2. So find the angle of that thing. So again, it's just going to use our shortcut. Take arctan of your y, so -3, or not y, your imaginary, and divide it by your real, -5, and see what that is. Notice that when we draw this thing out, -5 goes left, -3i goes down. We're down here in quadrant 3, so at the very end we're going to have to add 180 degrees because we're in one of those left quadrants. So let's go to the calculator. Oops. Let's come here. Let's do arctan of what were we doing? -3 over -5, which is the same thing as 3/5, but I can just do -3 over -5, 30. By the way, it doesn't matter where this negative goes. Like I could put it up here, and I'll still get 30.96. I want to round to 2 decimal places. It doesn't say where to do it in the notes. So 30.96, 30.96 degrees. But again, we have to add 180 degrees because what 30.96 degrees is, that's happening right there. If I add 180 degrees, that comes down there. And you can see, yeah, that's 180 degrees right there. So I'll say plus 180 degrees. And that gives us our final answer of 150.96 degrees. Go ahead and box it. What about example 3? Find the angle of that thing. So again, same setup. It's going to be arctan of 4 over 2, which is really just 2, right? And where is this thing? Let's go ahead and draw it really quickly. If I go 2 right, 4 up, 2 right, 4 up, it's in the first quadrant. And look, yeah, first quadrant, you don't have to add anything. So we're done after we do this. Let's come back over here to Khan Academy. So arctan of just 2, essentially. And that's 63.4. 63.43 degrees. And no extra addition. That's the end of our